Chapter 3, the gas law. Okay, so this entire chapter is dedicated to this point on study design. We need to know what gas law is, and we need to know the properties and definitions and every other requirements that comes with it. Okay, so first of all, kinetic molecular theory. Well, that sounds complicated. The good news is you will never be directly tested on this, so do not worry. So what does it do? It has to do with how people think about gas. So we need to understand the theory so as to understand why gas has its properties. So first of all, gases are composed of small particles. Yeah? And these particles, unlike particles in liquid and in solid, they are very, very far apart. Okay? They do not affect each other. And then the particles all have some energy, and they also move around. Okay. So what are some of the conditions that will affect these gas particles? So for example, what kind of conditions will affect how they move around, how close they are with each other? Of course, these properties: pressure, volume, amount, and temperature. We'll go through them one by one. Okay. Pressure. How is the gas pressure defined? Okay. It is defined as the force exerted on a unit of area on a surface by the particles of a gas as they collide with the surface. So you can imagine that for the same amount of gas particles, if they're full of energy, so for example, if I put them into a very, very high temperature, they're full of energy, they're very excited, then the same amount of gas will exert higher pressure as compared to if they are put into a fridge when they are cold. Yeah. So the units of pressure is a compound unit. Yeah, it's the force over a certain area, so meter squared. But we give them it's a name. It's called Pascal, and conversion of units is very obvious. It's kPa over 1,000 Pascal. In gas law, specifically, the unit for gas pressure is kPa. Okay. Sometimes we also talk about ATM. That's atmospheric. That's the gas pressure exerted on us by the atmosphere. Okay. So that's 101.3 kPa. Sometimes we also use millimeters of mercury to measure the pressure, gas pressure, especially atmospheric pressure. So 1 atm, that is 101.3 kPa, equals to 760 millimeters of mercury. Temperature. The units of temperature used in gas law is Kelvin. Okay? The conversion between Kelvin and Celsius is rather easy. So if it's 25 in your room, then it's 298 by Kelvin. Okay? Why do we use that system? Well, what does it mean? So we realize that 0 degrees normally, that does not, even at 0 degrees, all the particles will still have some kind of energy. But is there a point where even the particles in a solid stops vibrating? There is, and that is defined as 0K. So 0K is the lowest temperature theoretically possible. It is also called the absolute zero. So at this temperature, all molecules and atoms have minimum kinetic energy. Okay? So the person who came up with this scale, Kelvin scale, we call him Lord Kelvin, obviously. And his name is William Thomson. And he's really a genius. He's a prodigy. And he's buried next to Sir Isaac Newton at the moment. Okay. At our SLC, the temperature for Kelvin is 298 K. Volume. We're already very familiar with this unit. You are required to be adept at its conversion. Okay? So for example, can you convert 700 milliliters to these 3 units? So first of all, 1 milliliter is 1 centimeter cube. Okay, so 700 is 700. Okay, when it's converted to liters, you need to divide it by 1,000. Okay, And when you want to convert it to meters cube, you need to divide it by 10 to the negative 6. Okay? Mole. Well, the good thing is mole has only one unit. You don't need to worry about conversion. And obviously, the amount of gas particles present will affect its other properties, will affect the temperature, will affect the pressure and everything. Okay. So we have a certain set of questions. Yeah? How will all those quantities affect each other? If we increase the temperature of gas, will we also increase the pressure of gas as well? Or will we actually increase its volume? Or sometimes if we introduce more gas to the system, will this entire system have a higher pressure? Or if we lower the temperature at the same time, what will happen? So to answer all those questions, we came up with universal gas equation. Actually, it's not a theoretical equation. It's derived through experiment. It's PV equals nRT. So every quantity in this equation has its prescribed unit. Okay, it means that the temperature of gas multiplied by the amount and multiplied by a constant equals the pressure multiplied by its volume. Okay, so it captures the relationship among different quantities. You can imagine that if you increase the pressure, you might at the same time either increase the temperature, or you might have, it means that you have increased the amount. Okay, so this is the mathematical or numerical relationship between all those quantities. And the question is, what is this constant? Okay, so that is the molar gas constant. Okay, it is through experiment we realize that if you multiply the pressure and volume of a gas and divide it by its amount and temperature, its result is always the same, and that is the molar gas constant. It is in your data book. Okay, you realize that this constant comes with a set of units. What does that mean? That means whenever you're using the gas law, you need to always make sure that your units are correct, okay, as prescribed, because the unit of constant is already set. And finally, make sure that your temperature is converted to Kelvin. Okay, it is one of the most common mistakes in VCAA exams.